1979, the Voyager spacecraft showed a perfect geometric form over the North Pole. In October 2006, the Cassini craft found that it is still there.
It's just bizarre, and it sits there kind of still. It doesn't move with the planet. The pole, there's a hexagonal feature, a six-sided polygon that encircles the pole at about 78 degrees north latitude. And it's sitting there as a set feature.
The hexagon is similar to Earth's polar vortex, which has winds blowing in a circular fashion around the pole. Saturn's vortex can fit 4 Earths inside of it and extends 60 miles deep into Saturn's clouds.
And what's more bizarre, Voyager saw little tiny clouds going around at about 100 meters per second, which is about 200 miles an hour, going around this racetrack. People thought, well, maybe it's just a temporary thing. How could this stay there? It's been there now for at least 20 years, and we're going, what is this?
If you go there, you're going to enter these thick clouds. And the deeper you go, the more intense the pressure is going to get, to a point when you just implode. You and your spacecraft can't make it any farther.
For now, visits to Saturn's orbit are reserved for unmanned spacecraft. But surrounding the planet are at least 48 moons. Venturing to one of those is more feasible.
What's interesting now that we're going to the planets is that we're learning that in some ways the moons are where the action is.
We've already been to one of them. Titan is the only moon other than our own to have been explored. The event was beyond significant. On January 14, 2005, science fiction became fact. As part of the ongoing Cassini mission to Saturn, the unmanned Huygens probe descended onto the surface of Saturn's biggest moon. Titan lives up to its name. It is the size of the planet Mercury. In fact, it is the second largest moon in the solar system, 50% bigger than our moon. It is seductive in many ways. For one, Titan looks much like Earth.
That was the thing that hit me over the head. Just how remarkably similar in process the surface of Titan looked. We have river channels that feed into these lake beds. We have winds. And then in other areas, we have dunes. The equator region of Titan, at least on one side where we've gotten good radar imagery, has hundreds and hundreds of miles of these dunes that are 100 meters high, several miles apart, and they just go on, this vast sea of dunes.
There are possibly deposits of solid hydrocarbons.
And we didn't really know until that probe landed whether it was going to hit liquid or some solid surface. It seemed to kind of fall on what looks like kind of pudding. It doesn't seem to be liquid or solid. It seems that Titan has some goo on the surface. It's almost kind of neither land nor sea, but something in between. That's very amazing.
Amazingly, Titan, like Earth, has an extended atmosphere. no other moon does in our solar system.
The atmosphere of Titan is very, very thick, very, very massive. It has a mass that's 10 times the mass of the Earth's atmosphere. And so we have a very, very thick layer of gases. So it's thicker than the air as we know it. The particles in the air are also very small, and so I would characterize them more as a haze than as a fog or clouds.
The haze is 200 miles thick, resembling something else on Earth.
From the outside, it appears essentially opaque, like a big orange ball. But as the Huygens probe descended through the atmosphere, it's transparent enough to be able to see the surface features as it fell through. But it's not unlike a hazy day here in Los Angeles.
It's not the color of the atmosphere that most intrigues scientists. It's the composition. Nitrogen and methane, the same gases they believe made up much of Earth's early atmosphere.
The idea that Titan's atmosphere mimics the atmosphere of early Earth 4 billion years ago is something we're very, very excited about and interested in, and it's one of the things we're studying very hard in our laboratory. So let's see if we can get this aligned. What do we have?
At the University of Colorado, Dr. Margaret Tolbert is simulating Titan's atmosphere in her lab. Might it, too, have the necessary ingredients for life?
In this experiment, we're trying to simulate the chemistry that goes on high in Titan's atmosphere where the haze is forming. And so what we have is a reaction chamber here, and all that we have in there is nitrogen and methane. So the two most important components of Titan's atmosphere. And then we're just going to flick on a lamp, and that lamp is going to simulate the sunlight hitting Titan's atmosphere.
Incredibly, Tolbert's research has shown that Titan's atmosphere, when stimulated by sunlight, begins to produce organic compounds. To scientists looking for life beyond our planet, this could be big.